My name is Dimitrios Tsoukalas. I'm a senior research associate at the Center of Research and Technology, Hellas, and I will give you a brief presentation regarding the ITI Smart Home. So first of all, a few words about the smart home pilot concept. The ITI Smart Home is located at the CERTH premises, and it's Greece's first house that combines advanced construction materials with intelligent ICT solutions, therefore acting as an active testbed in various European as well as national research projects. It offers a lot of innovative IoT-based technologies and solutions, including energy, health, and of course, artificial intelligence, among others. And practically, the house is a single two-floor building, which is divided into two main sections, including the main household, three auxiliary rooms, and a lot of other rooms on the left and right wings of the building. So, as it is obvious, to support the various intelligent ICT solutions.
Sorry, Dimitrios, I just want to stop you.
Yeah, this background noise.
Because there's some background noise, and so maybe if people could mute themselves, yes, that'd be great. I'll mute myself too.
Sorry for this.
No, it's not your problem.
Public space.
No, it's not your fault. It's just some background noise, so it's not you.
Yeah.
Thank you very much.
So as it is obvious, to support the various intelligent ICT solutions, the smart home is equipped with a large set of heterogeneous devices, such as smart lights, sensors, actuators, appliances, etc. And these devices generate data continuously. So the figure in this slide presents a high-level overview of the network topology of the smart home infrastructure, along with some installed sensors, actuators, local servers, and devices. And as it is natural, data exchange among these devices is performed via several different communication protocols, such as ZigBee, LoRa, MQTT, and so on and so forth. Besides the network topology, in this slide, I illustrate to you a high-level overview of the smart home architecture with respect to the data that flows through its devices. As you can see, IoT devices produce measurements that are sent to the smart home backend server, as said before, via different communication protocols. And therefore, a smart home gateway is deployed on the backend server, which is, of course, responsible for managing the communication among these devices. Now, when data from the devices arrive to the backend server, they are stored in a dedicated smart home internal database, and subsequently they can be distributed to external systems through the smart home RESTful API, whose endpoints are, of course, consumed by other auxiliary and other systems, and by the users of the smart home via the smart home dashboard. So from the above description, it is obvious that this constant exchange of information from the IoT devices implies a large attack surface, which is very difficult to control. And as said, the smart home is equipped with a large set of sensors, device access, etc. However, although the smart home functionalities are absolutely security sensitive, most of the installed devices are bought off the shelf and are deployed without any validation, meaning that their security and, of course, reliability were taken as granted. Of course, taking security as granted, even for devices constructed by well-known manufacturers, is not a good security practice. So to address this challenge, the figure in the slide shows the new components that will be added within the context of the DOSS project, which are colored in red. Specifically, during the project and for demonstration purposes, we're going to prepare device security passports for a set of new devices that we will aim to install within the smart home, and we will apply diverse testing methodologies on the components used by these devices. And subsequently, we plan to virtualize a subset of the smart home architecture where these devices will reside, and redesign it from a security perspective inside the smart home's digital cybersecurity twin, using the verified components that we verified in the previous step. And in that way, the foreseen secure by design exercise will be modeling the security status of the architecture and thus discover hidden design bugs, vulnerabilities, unknown threats, and of course recommend additional protective measurements. Finally, the new devices, secure devices, will be added to the actual smart home architecture using the DOSS secure onboarding platform, which Andreas mentioned previously. So this is pretty much the objective of the pilot. And as the project progresses, we believe that incorporating in the smart home the novel DOSS security hardware and software solutions will, of course, enhance the overall security of the environment.